Hi, everyone. I'm super excited to be here, and thank you for joining me. Let me start from a quick question. Do you feel that you are responsible or accountable for quality to some degree at least? Like, raise your hand if it is so. So that's really great because I would like to talk about how to empower everyone generally to be responsible for quality. So the main idea will be about key decentralization today. So I will talk about what it does it mean. And to be able to do that, to be able to decentralize key engineers generally, we have to do a lot before. So we'll talk about the requisites for that, then roles and responsibilities, how to measure success, some horizontal approaches which helps us, and results and consequences. Because I can't say that this is a fully successful story. So there are pros and cons, and we will talk about that. About the key decentralization, what does it mean? It is a simple story. We had centralized management for key engineers previously. They were embedded to product teams for a time, of course, but key leads were managers for key engineers. So now we are changing that. But in reality, our goal is not about that, of course, because previously our engineering managers could ask us if you would like to force us to be responsible for quality indicators, why the main resource who is helping us for that is not under our control. And it is absolutely valid concern. So our idea is to make our teams autonomous in order to achieve quality goals as well, make them accountable. And during this journey, our engineering grew from 20 engineers in total in engineering to more than 700 people in engineering. So we were trying to identify what is a scalable approach, how to manage quality. And there are still key leads, there are still key engineers, and I still working in Miro, and it is a matrix system generally. So we became more like dotted line managers, how to ensure quality. I would like to talk about prerequisites because actually people started asking me about why key structure is centralized from the first day of working in Miro. But it was not possible at all when you don't have really fundamental part of that. And the first one is a process. So we needed to define how our development process should look like. I will not pay attention to that a lot. There is a QR code to my article on Medium that was posted some time ago, and it is still actual. I will go through this quickly. The first part is accepting user story. So product manager brings idea to the team, and the team has to get this fully without any questions about the details, how this feature should work. We use 3 Omega sessions, story mapping, example mapping, and a lot of different frameworks to decompose the story fully and to get all the needed details from the beginning. Generally, we stick with the approach of shift-left testing, and the shift-left testing in our case is not that key engineer participates from the beginning. It is more about to get rid of testing as a stage and to have quality on each stage of development. So it is the first part where we are considering what we need to implement. The next is a refinement. It is more technical part where our developers should go, should look through the code and to get technical details, not just decompose the task theoretically, to really consider how the technical implementation should look like, and initial problem statement should be adjusted if it is impossible to implement something created on a previous step. Then planning is a simple story once we have everything implemented before. So we just need to put implemented, I mean defined clearly. And it is just simple task to move prepared initiatives to the sprint and define outcome-oriented and customer-oriented goal for the sprint. Then development, here I would pay attention on that, again, our team's autonomous. It is up to them to decide who is doing what. But what we control, that key engineers are not people who test something after developers. So if we defined everything from the beginning, we do not need to have dedicated person who will do this work instead of developers because of some reasons. At the same time, key engineers can do, some automation tests or prepare something else, maybe, like different things. And if you would like to deep dive into that, so we can discuss it later. The release is a part when we actually have this code already in production. In most cases, it is hidden from our customers by feature toggle. And at this moment, once it is already in production, we can do exploratory testing. It is a part that QA engineer can do. And positive testing, like happy paths and such kind of things, might be done by product managers, designers, developers, somebody else. The idea that a QA engineer didn't participate a lot during the development, and his mind is fresh, and they can double check that really it works, and there are no really edge cases that we couldn't predict, and so it is an additional double check. This is the result of this process. Generally, in our case, there are two features to compare. And you could see that generally quality and speed are not contradictive things, because once we predicted everything and covered it by test even during the development, it can help us to reduce number of iterations. So in reality, it means that lead time will be much faster and the number of bugs is significantly less. So it is really so, and before rolling it out to our the entire engineering, we checked it in different teams, in different domains, and it worked really in a similar way. Then a little bit about technical part of that. So it is more maybe unique for us, and also if you have any questions, I can share any insights about that. Idea for us is to pay attention a lot on unit testing, because you probably know what is a Miro as a product. It is a whiteboard. Where it is a big freedom for our customers how to operate with widgets on this board. So generally, what is a happy path? Like how our customers use our product? It is not really clear, because it might be different generally. So variability has to be covered on low-level testing, and because of that, we are paying attention a lot on unit testing, even on the front end. Then on the back end, we have some part implemented in microservices, and our approach is to keep, of course, contracts safe, and we decided to choose schema validation for that. Then integration testing, and we agreed that integration testing is about integration between entities which are more than class. So it might be between classes, services, microservices, something else. And those are needed to be covered as well. It is also some part of low-level testing, which is crucial for us. Then API testing, the difference is that it is again started application, not just something like using Spring Boot or something like this. It is a real end-to-end testing, end-to-end meaning that we are checking application as a whole, as a black box. And primarily, we use it for critical user journeys as well as UI testing. UI testing for backend parts is forbidden generally, excluding this point when we need to check critical user journeys. And we also have performance testing, mostly for top 20 API endpoints, and measure use cases for the board server, which is a backend for our canvas, like the main functionality that we have in Miro. Then again, we rely on unit testing a lot on the front end. Then visual regression testing is an approach based on playwright. It is for elementary components. For example, if we created sticker and we need to check that it was rendered as a yellow sticker, we do not need to have backend. We do not need to spin up the whole front end for that. Such elementary components we need to check in isolation. But again, it is based on playwright. It means that we are checking real rendering. Same for like design system components and such kind of things. Then we have end-to-end UI testing, of course, and we use Canvas a lot. Because of that, we have a lot of like screenshot testing, and it is quite heavy approach how to like check needed parts, how to validate that it was really rendered correctly. And this framework is based on Playwright as well. And this is a basic library for us, and all other approaches are implemented in one place. And then talking about cross devices, we also have mobile applications. We have a specific application for Surface Hub. We need to test different versions of browser, different browsers, and future versions of browser. For example, they sometimes break us completely, and we need to know about that in advance to prepare some catch while they are fixing something on their side. Also, we have additional functionality to test accessibility, localization, a lot of such kind of things. The main idea that we add this functionality to Spectator. This is a like basic library for UI testing as well, even if there is another engine to execute those tests. For example, for cross-device, we use Appium, but like basic ideas, for example, how to check I don't know, widget creating, for example, is implemented once and might be used in different engines, like based on Playwright and Appium. It is consolidated in one place. And client performance testing, there are a lot of different tools to do that. So also, if you have any questions related to this topic, we can discuss it in detail. I will not pay attention on it a lot. Then infrastructure, and it is an ongoing initiative that we have at the moment. So it is a like, new challenge that we are facing now. Maybe somewhere in the future we will meet each other one more time and I will discuss it in detail. The idea is that if we are involving our developers a lot, we have to ensure that local testing is convenient. Also, local testing empowers to develop components in isolation, because if you need to start this like your changing component somehow locally, we need to know dependencies, we need to know how to mock them, how to work with them, and it is really great in terms of how to build really scalable and simple architecture for the future. So it is really great thing, and like it is some of the focuses that we're having now. Then develop environment, it was created mostly for front-end developers. The idea that front-end developers would like to have only client started locally and client side, and then to work with remotely started like backend somewhere. So for that we have develop environment, but there are also opportunities to have only started my microservice in like my local machine and to connect with the rest of the services started remotely as well. It is quite dangerous things, to be honest, because, for example, if you can do that, if you can only start my microservice and without clarity how the rest is working, like just check my microservice, it can cause such kind of problems like distributed monoliths between microservices, because I don't know what dependencies are. I just can test it. So it is quite like dangerous thing. And pre-production, it is an absolutely similar environment to production, and we have to check everything there right before going to production. Everything is generally like application changes, configuration, infrastructure, really everything. Then once we implemented all those things like processes, tooling, and infrastructure, like we have all the technical capabilities to ensure quality. Now probably it is a good time to delegate ensuring quality to teams. So at this moment, we decided that it is a good time to consider that we can make QA decentralization. Our model is QA lead based, so it means that every department, we name them streams, has one QA lead. It is a like head of QA for one of the departments. We have 5 departments, and we have 5 QA leads who are generally head of QA. It was quite challenging study to complete this because, like we will talk about the role itself, like it is quite difficult to hire 5 really great, so experienced people. Then, if we have interconnections in the product, how to make teams autonomous. So, one of the teams is responsible for one feature, another for another feature. In code and in product, they are connected. And if we change this one, another one will be affected. So it is a huge challenge for us, and we couldn't solve it, of course, but we could develop QA strategies on all streams really clearly. What is a problematic area, how to maybe handle tickets that we can get there, or like how can we improve quality there, and establish knowledge sharing between streams. And if we touch this, another stream should know about that somehow. And the last one is about engineering structure. It was historically based on product. So we have different functionality in our product, and those capabilities were spread by our teams. But some of the technical components which don't have this customer-facing part might not have clear ownership. So we also couldn't maybe solve it at the moment just because of QA needs. I mean, we can't restructure the whole engineering because of that, but we could clarify ownership. Then let's talk about roles and responsibilities, starting from QA lead role. There is another article where I described what is a QA lead role in detail. It was published before the QA decentralization, and there are 2 major changes. The first is previously, QA leads were people managers for QA engineers. So because of that, we needed to have like nested structure of leads, because if there are too many QA engineers, like they can't manage more than 6 or 8 people. And because of that, we had several QA leads for one stream. And now, manager, it is not a management role anymore. Obviously, because there are no direct reports anymore, and because that it becomes IC role. It is close to staff engineer role, I would say, when we need to drive like programs, projects, something like this across different teams and even sometimes streams. And it is more technical management, technical maybe leadership even, maybe better to say. So it is not managerial role anymore, it is more leadership role at the moment. With again, technical background. The second idea is like if we don't have this people management, there is no necessity to have so nested structure, and we can have only one QA lead for one stream, and it means that the scope became much bigger. Here is the matrix for all the maybe measure roles in the team. And the QA engineer is a person who is also individual contributor. So we really require some results and outcomes from this person. It is like, because once we want to implement something like all people are responsible for quality, it might cause something like I will go to team to coach them how to work with quality, but I will do nothing. It is not the case, because especially after decentralization, engineering managers require real results from their teammates. So because of that, there is still the idea that they will establish maybe some practices, share, coach people, but you can see a lot of responsibilities there related to ownership, strategies, quality indicators, tooling, guidelines, competencies like across the entire team, career progression, and like attendance. So they are responsible almost for everything within the team.
What does EM stand for?
EM is an engineering manager. It is actually team lead for the team. Yeah, thank you for the clarification, because it might be not so clear. And yeah, actually team leads became accountable for quality. So now we can ask them about quality expectations if they don't follow them. QA lead role became a more consulting role because it is like first of all, as a head of QA role, more strategic thing. So they can see the big picture, what is happening in their organization, define some quality gaps, and to bridge them somehow. How generally they can deep dive into some particular case and help engineering manager or QA lead or even developers to solve it in some way. And because of that, it is a consulting role. But at the same time, you can see accountability for adjusting common tools and practices, preparing guidelines, and we will talk about that a bit later, and help engineering manager to work with competencies. Head of QA role, to be honest, didn't change significantly. QA leads were my direct reports before, now it is not so, but generally I can't be everywhere. I can't work with 5 different departments at the same time. So it was more or less the same way of working for me. Small maybe comment about career matrix. And previously, once we had QA leads as a manager for QA engineers, if there is no something crystal clear, it wasn't a problem at all, because QA leads could describe by example what we expect, how their behavior should look like, such kind of things. Here, after the decentralization, engineering managers became responsible for career progression for QA engineers, and engineering managers are not experts in QA craft. So if we expect something from QA engineers, engineering managers should know about that really clear. And we, for example, had a case when we mixed roles and responsibilities. For example, we expected from every QA engineer that a QA engineer should establish QA process within the team. It is possible only if you are senior. If you are, I don't know, middle even, it is too much to expect from QA engineer. So it is a role description. It is not so it is not a role description. It is a part of the competences specifically for senior level. And we needed to clarify such kind of moments because otherwise there are too many questions from engineering managers. Then how to measure quality. As you could see, we had quite a lot of initiatives related to processes. And because of that, our metric system was focusing on outputs more. So it means that we are measuring something to see that process is working well. But when, again, engineering managers started being responsible for such metrics, they also asked, why do we need to have this process? It is also a valid question. And because of that, we needed to reform our metrics to more outcome-oriented. When the metric leads a real result, it is much clearer why do we need to have this, because the result is more obvious. So now our system of the metrics is quite simple, because if you have so long dashboard of metrics, they don't really know how to follow that. So we have only 4 measure metrics at the moment in 2 buckets. The first bucket is bug density, second is stability. First metrics, to be honest, are also output-oriented and quite operational. The first metric is the percentage of bugs that we can fix on time. On time means, for example, we have SLA for measure, and measures should be fixed in 7 days. So how many bugs were fixed in 7 days? And for broker bugs, we don't have SLA because it should be fixed immediately. And what immediately means is actually absolute number. So we have to check, for example, in average or in some percentile, what is our mean time to resolve for broker bugs. But again, we are talking about bugs. So there are 2 different things. One of those is stability, another one is quality. Those are different things. Stability is more about how production behaves. Quality is about how we prevent such kind of issues before production. And again, it is quality metrics. So we have to be sure that we are checking such things which help us to prevent such kind of issues. So because of that, the focus on bug density. Density can show you components, for example, where you can bugs frequently, and it is an insight for you that it is better to check this component, maybe the factor that something like this. So we are focusing on such operational metrics, but if we see any kind of issues there, we can drill down, see a lot of other metrics which are focusing on bug density, focusing on prevention. Then testability. Testability in our case is not that our application has convenient locators or something like this. Idea is to make our application testable first, and then to understand how it might be covered by tests. So because of that, we are talking about test coverage here in a broader meaning than just like unit test coverage. It is considering functional test coverage, and we checking like critical flows coverage there. And second bucket is the test efficiency, because of course, if you have too many tests but they are not efficient, it doesn't make a lot of sense. And test efficiency consists of two parts, speed and flakiness. And we achieved maybe the highest speed that we could from technological perspective. Because of that, we are focusing on flakiness. So our CI/CD pipelines are fully automated. As I said, like we don't have manual regression and such kind of things. And our release scripts will release a product only if all tests are passed, like thousands of tests. So it means that our tests should be extremely stable. Next idea is about moving from QA guild to QA community. Generally, also previously we had QA engineers, and QA engineers could work with several teams. To be honest, it is not true. If one of the QA engineers, for example, works with 5 teams, they can attend all the meetings for all the 5 teams, and there is a primary team. But engineering managers feel that there is a QA engineer. So after the QA decentralization, one of the engineering managers became a manager, and focus for this QA engineer naturally became on one team. So some of the teams are without QA engineers. And because of that, we have to have any kind of like horizontal community which helps us to develop practices together, be aligned about QA goals, targets, and onboard engineers, and sync product teams and QA enablement. We will talk about that a little bit later. And collecting feedback analysis. So again, it is a horizontal community where all interested people who are from our product teams can work together. Then QA enablement. Simply speaking, those are like dedicated teams which are responsible for establishing test frameworks, test platform in general. It is about how to select tests, build them, run, parallel, do everything. And infrastructure, again, such kind of things, and for that we have dedicated teams. How it works in general. The whole idea is that we start from QA enablement, and together with QA leads, we work as a group of people to identify what is our strategy. So, by example, if you work in microservices, we would like to save our contracts between microservices, and we are defining what is an approach for us. As I said, our approach is a schema validation. So it is a strategy generally, like we use schema validation for contracts. Then we implement needed tooling and infrastructure for that. For example, we implement buff for gRPC, and we do not implement like packed.io and contract testing in our company. So it enables us to use right tooling. Then we have to understand how to use that. We have to create some kind of guidelines about, again, how it might be used. QA community and actually people who really use it on a daily basis know it better. And because of that, together with QA leads again, together with people from product teams, we develop those practices. Then if one of the teams, for example, started using it first time, and they would like to ask about that, they will ask QA community, not people who implemented those frameworks. Again, because dedicated teams who implemented test framework, for example, they even don't know in like what is a, I don't know, practical approach how to use that. So they will ask people who really use it on a daily basis, and people answer questions to each other. They contribute to those practices together. And it is much more scalable approach. Like in dedicated teams, there are 5 or 4 people, for example. In QA community, dozens and hundreds of people, and they can answer like their questions. So once we have standards and principles, we need to drive real adoption in our teams. For example, again, if our idea is to cover all the contracts by schema validation, it should be done at some point. And again, we have QA leads. QA leads know clearly what are the problems in their streams, and they can sell the idea why do we need to, like, for example, cover all the existing microservices by schema validation in the next quarter, and they can really share all the idea why, like what is the risk is if we are not doing such kind of things. And finally, we can have KRs or something like this, which will drive us to do that in the next quarter, for example. So it works in this way, starting from strategy, then empowering by needed toolings, then developing practices together, and adoption is driven by real goals in teams. Consequences of the key decentralization, as I said, is that we have quite a lot of teams that are without key engineers at the moment. More than half of our teams are without key engineers. It is okay if teams are autonomous. Again, it is up to them to decide, do they have scope for dedicated person who will be responsible for quality-related topics or not? So if yes, they can hire or keep a key engineer. If not, it is up to them to decide. Then again, engineering managers will require real outcomes. So because of that, they will ask them to participate, to write tests, to deep dive into some particular technical areas, do some performance, for example, testing or something special. And it will require much more technical knowledge and again, bring those results. There is no room for global initiatives because there are 5 absolutely independent streams. If you have an initiative that should be across the whole engineering, so how to do that? So they have their own goals. And they develop their strategies as well. They know how to and in which direction they need to move their quality. And it requires consolidation and quite a lot of effort to be able to direct all of them in a single direction. And we still need that because we work on one product and we can't be fully autonomous in order to move in absolutely different directions. And sorry, what was happened? Just a second. How is it possible? Then maybe about benefits. I will start. The first benefit is that our KPIs are on an unbelievable level at the moment. We have never seen such high numbers. It really works when people really engaged. Then, if we had any kind of conflict or something like, for example, QA engineer and engineering manager have different opinions about what is equality and how to work on equality-related topics. Before that, engineering manager could say that, okay, it is not my responsibility. They, together with QA lead, will decide something. But now, QA lead is not really a part of the team, and engineering manager should know how my teammate works. So such conflicts became much more visible, and we could solve them. So it is also a benefit that we knew about that. Quality became engineering strategy pillar, and the idea is that generally QA people were like responsible for common tooling, and for a long time we didn't have dedicated teams and developed test frameworks and practices by people who were embedded to product teams. So they had two different types of work in the team and somewhere else. So now we don't have such kind of opportunities to have two absolutely different focuses. That is it. Thanks a lot for listening.
Okay, thank you, Anton, for your presentation. Are there any questions? A lot of.
Yes, thank you for the talk, and actually quite useful for us to see the results that you get, and can reuse your experience and try to achieve the same results. And my question will be connected to that slide, to this section. And what about the performance of the team? So is this change somehow impacted or increased or decreased? So since engineers also will care about QA, so is it slow you down or against that? Your thoughts about that? Thank you.
Yeah, good question. And actually, it was one of the metrics that we also controlled during the QA decentralization. We didn't notice any changes, and we didn't expect any improvements there. To be honest, at the same time, we had quite a lot of initiatives to improve productivity in general. So because of that, we saw the improvements, but I don't think that it is because of those changes. Our goal was not to slow down the process. And again, nothing dramatically changed immediately. We were preparing all those things step by step, and generally now it couldn't affect us significantly, and it wasn't so.
Thank you for your talk. Very interesting. And our company is also on a similar QA journey where we decentralize QA. And one of the things we also introduced in the shift left testing. And did you face any challenge with adopting shift left by engineers? For example, in our cases, we also don't have dedicated QA engineers with all the teams now, but some of engineers, they are not used to write tests or not used to participate in QA activities. They got used to just, I build my feature and I hand it over to QA and I wait feedback at some point. So are there any tips? Because I guess at your scale, you will have a lot of probably similar situations.
Yeah, maybe the first idea that it was one of the arguments for me to say no for the QA decentralization, because I felt such kind of issues when people were not prepared to that. So if you know such cases and if it is quite significant for you, maybe most of teams have such kind of issues, it is better not to do QA decentralization from my perspective. At the same time, there is another maybe problem. If we have dedicated focus on end-to-end testing, we have quite a lot of end-to-end testing, and we still have a lot. So because of that, generally it is not a bad situation when developers don't write end-to-end testing. It is okay. And generally, they really should at least like low-level testing and rely on integration testing rather than API testing, for example. And it is great. It is much more efficient. So the idea that it can also lead this fixing test pyramids once you have that. And because of that, if you need end-to-end testing, for example, you need to have clear goals for that. For example, now we have again too many tests, and we would like to cover only critical user journeys by end-to-end testing. So it is quite easy task to control critical user journeys, and it is even better if teams decide not to test something by end-to-end testing. So it looks as a downside, but in reality it is more benefit if you really enable low-level testing, but it is so in our case.
Thank you very much. One more question. You mentioned QA community. I think that's also a great way to introduce QA practices to create this mindset of shared quality responsibilities. Can you elaborate a bit more? How often do you meet? What ceremonies? So how did you implement? What the steps? So if you have an engineering team of 100 people, how would you approach? Is it like bi-weekly? Who should lead? Is it like QA lead, or is this like principal QA engineers who lead this group?
Also good question, and I talked to a lot of companies to learn how they work on it, because there are absolutely controversial ideas. For example, to have one representative from each team who must join this QA community to be in touch like in quality related topics. It is not our approach, again, because we have QA leads. And if you have one person who is responsible for 20 people, like teams, it is a huge scope, but still, like it is doable to know which teams are there, like who is responsible for what, and if there is somebody who is interested in performance testing, for example, they will be able to join and invite such kind of people. So the idea is not that like people are joining those communities and they transfer the knowledge or maybe contribute to all quality-related topics. It usually works like this. Like one of the developers, because of some reasons, like performance testing. So there is an opportunity for him. Another person likes, I don't know, something else, accessibility because of some reasons. And she probably will join like the QA community. So it took a year for us to spin up it and to have it really in active way. And now it is quite active, I would say. So we have a community channel on Slack. And as I said, people can ask questions and the rest of QA community will answer. And it works now. We have QA meetings every week, and generally topics appear there also naturally, so just anyone can add something to share, to ask, or do something else. And on a weekly basis, we have meetings usually. Sometimes we don't have, but in like almost all weeks with a QA meeting. So it means that people are also engaged. So our approach is more natural. It is quite hard, but again, we have specific role QA lead who can drive it inside teams and streams.
Okay, I think we have a bit time for a last question.
Thank you for your talk. Definitely will take something to implement. Question about money. The budget, did it change it since you applied these changes, or you stay with the same structure of QA department, or maybe something less now, or maybe more people, or more, I don't know, seniority people?
Maybe I would say that it wasn't changed, because generally we didn't fire people because of decentralization, so people are the same. And
Maybe you need more senior people?
It is true, and for example, half of our key leads needed to be changed, and we hired really mature and like high-level managers. So because of that, like maybe yes. At the same time, in Miro, generally we hire quite mature people and like talented people. So of course, like there is a big difference between senior, for example, and principal engineer. But in our case, maybe we do not pay attention to that a lot because it is an investment which will give you a lot back. So because of that, yes, if you take a look at on a budget isolation, probably yes, but we like don't really like consider it in this way only because it is an investment.
Yeah, thank you. And another question, if I may, about the releases. You said you need to have a green light from all tests passed, right? Thousands of tests.
Yeah.
How often do you release, and how
So,
it looks like?
Several times per day, and
But you need to wait also for UI end-to-end tests.
Correct.
And how many tests? How long does it take? Do your developers frustrating? Are your developers frustrating a lot with that or not?
yes, it is quite significant, and like we implemented a lot like during the last year. because, for example, we don't test everything on like for branches, and we are trying to have conscious and like on-the-fly detected like suit what do we need to test there. So on the branches it doesn't take really a lot of time. Then once code merged to master, we checked all the masters, and there we execute all the tests, so thousands. But even talking about UI testing, for example, most of those tests are screenshot testing. And because of that, even considering that, 5, for example, 1,000 tests might be executed in 10 minutes on average. Because we invested a lot to that, and we use a lot of machines in parallel, so it works quite quickly. But the problem is flakiness is never gone. It is not possible to solve it completely, and because of that, we have different practices to mute tests. And for example, if there is a test and we have to mute it, there are 2 opportunities. It might be muted because of a problem with test, and if it is so, actually it is something similar like test passed. If there is an issue, bug will be created, will be connected to this muted test, and the list script will see that there is a actually failure test which has a linked issue, and we have to wait until this issue is fixed. And to be able to solve this issue, also implemented like merge queues and such kind of things to roll back wrong changes quickly. So in this case, we will roll back this change and release the version without wrong code inside.
Okay, so looks like we can wrap it up. If you have any other questions, we can discuss it later after presentation. And thank you, Anton. Thanks for your question.
Thanks a lot.